Greetings everyone! Today I will review a LED fixture from AliExpress that I already tested. Since I came a long way in my testing methodology, I decided to evaluate this fixture again. It is sold by DJworld in the price range of 30 to 40 euros. I bought one during a sale and paid around 25 euros in total. They promised 260 watts of light output with RGBW. Nothing fancy, but also nothing less. Let's see how the fixture fares. I will use my updated equipment and methodology that I explained in detail in my review of the Shed 7x18 watt metal fixture. This is a technical review from the point of view of an engineer, so be prepared for some graphs and tables. Let's get right in. Overview and functions. First, let's think about where in the product stack this PAR sits. I would say this PAR slots right in the middle of the classic Chinese LED PAR product stack. On the bottom is the 7x12 watt RGBW PAR, then as a step up comes the unit we are reviewing today, and the high end is being represented by two versions of the 18x12 watt RGBW LED PAR with a metal casing. From a product stack point of view, this fixture today presents itself as offering the same amount of power as the big ones, with the drawback of being the plastic case. In some sense, this is the cheap man's washlight. Since DJworld has updated their product page, I am interested on what they say about their fixture. They claim compatibility with worldwide power delivering 216 watts of power consumption, 18x12 watt RGBW LEDs, 4 or 8 DMX channels, a shuttle that has a flash rate of 0 to 10 Hz, spoiler, not even that is true, a mechanical dimmer, lol, and a long lifespan of the LEDs. Then they have a nice but absolutely idiotic graph with some beam angle where nothing really lines up, and it claims that it has a beam angle of 3 or 40, something in that range, and the sticker on the PAR itself tells us that the beam angle is 40 degrees. On the right are pictures of the main board, which uses a high-tech constant current circuit board, which I understand, and has a strong anti-in, which I don't understand. The cooling fan is fast and keeps the equipment in the best condition. They claim that you get all this for only 30 to 40 euros, and I'm interested in how many of these claims actually hold true. The internals are as follows. First, there is a power supply board. This outputs roughly 23.4 volts and puts them into the dimmer board. The dimmer then takes this voltage and sends the power to the LEDs. While being at this, the dimmer also sends the 24 volts straight to the little case fan. The LEDs themselves are mounted on the custom-made aluminum PCB, which acts as a rudimentary heatsink. Materials and build quality. The casing is cheaply made via injection molding, like really cheaply. You can even see the scratches of the milling done to the injection molding form on the bottom right picture. You will not be able to break it as easily as the 7x12 watt fixture, but this is also far from good. The only metal part of the fixture is the steel front plate, which holds the LED lenses. The U-brackets are also horrible, but are capable of holding the fixture. For power, the fixture uses two C14 connectors. As stated, the selling point of the fixture is power, not the case, so as expected, there is nothing fancy to see here in the case section. Fan and noise. The unit uses a fan to cool the LEDs. The fan is unfortunately not temperature controlled and runs straight from the 24 volts of the power supply. This leaves us with a quite noisy fan, even if I have seen worse. Just for your information, the unit I bought does not have the same fan as advertised on the website, but that doesn't say anything since there is a significant time delay between me buying them and them updating the site. And it is common to use multiple suppliers for such things anyway. And by the way, I just realized that I need a good noise meter to test the loudness of the things I buy. Cooling design. The cooling only consists of a singular large aluminum PCB, that is the heatsink. It is being blown on by the case fan and thus stays relatively cool. The temperature is nothing to write home about in the stock configuration, thus I did not test it. Generally speaking, we would expect a way beefier cooling solution for a fixture that actually had 216 watts. Compliance. The DJworld PAR has no compliance whatsoever. Granted, they put a shiny CE sticker on the case, but that doesn't really count. This basically disqualifies this product for use inside of the EU, since that means that you will be liable for potential damages that this fixture could inflict. This is bad if a house burns down. It is catastrophic if a person gets hurt. Besides the fact that you're theoretically not allowed to buy the unit in the EU if it has no CE sticker. Interestingly, the PAR comes from Czechia and thus already was in the EU, and you are technically not the importer. Make of that what you will. LEDs, subjective evaluation. Before going into the details of the measurements, I want to present a small subjective evaluation. The LEDs are definitely quite bright. The dimming curve for red is atrocious and the worst I have ever seen. Just from looking at it, I would expect a beam angle of 25 degrees. Then I proceeded to measure the brightness and the beam angle of the unit. I did that with the brightness sensor of a Samsung Galaxy S20 FE, so not the most accurate thing, but I think it would be fine, or it should be fine for relative comparisons. This leads us to a maximum brightness of around 2300 lux and a beam angle of 12 degrees for 1/2 and 21 degrees for 1/10 of the maximum brightness. As a quick information, the LEDs are 3 parallel sets of 6 LEDs in series. So the current values for all the 18 LEDs and the voltage is 2. You have to keep that in mind for understanding the table I present to you. They advertise the power of the LEDs being 12 watt. That is not true, with my measurements telling me an LED power of 5.5 watt per LED. In total, this would add up to almost 100 watts. Again, the obligatory disclaimer here. The maximum safe voltage of an LED is not a number set in stone. Every LED can have every possible power. The only question is how long it is able to sustain it, with overdriven LEDs lasting only minutes to milliseconds. In the ideal world, one would use a constant current driving method. This leads to manufacturers only giving out a rough estimate for the voltage in favor of a fixed current rating. This unit, however, does not use a constant current driving method, but only applies a constant voltage. With a constant voltage, you need to use the voltage as the defining number for limiting, or rather setting, the power. For my measurements, I just took forward voltages as I deemed them good. They are what I found to be generally accepted forward voltages of LEDs. But again, this is not how LEDs are supposed to be driven. This means all this from the manufacturer's 12 watts all the way to my measurements is highly flawed. I could use a CC method, but since I have no way of knowing the exact type of LED, I have no idea what the current would be. Anyway, the actual max power is definitely way lower than advertised, and I suspect this is not only because of my flawed measurements. Dimmer board evaluation. We can see the dimmer board on the right here. It is a pretty straightforward board. The central chip is the brain of the fixture that sends out the PWM signal. This signal then gets amplified by these MOSFETs on the top, so that the LEDs are getting the actual power. And this is also the moment we realize that the LEDs are not driven with a constant current method, since, well, there is no circuitry for that. With that out of the way, let's get to the measurements. I have explained my methodology in more detail in my review of the 7x18 watt RGBW AUV sheds PAR, but here's the TLDR. The dimming works via PWM, which is the standard way of dimming LEDs. The voltage looks like the picture on the top. From that we can get the PWM duty cycle and the maximum voltage during on. The switching frequency is also measured here. For this dimming board, it is 23.4 kHz, which is quite fast, and definitely done in a way that there is no visible flickering, even for cameras. Additionally, I measured the on current the LEDs get during the pulse. This was made a bit tricky because, as you may be able to perceive, there is a current spike at the start of every pulse. I marked that with a big fat arrow pointing at the spike. These are the most important data points I got with this method. The peak voltage is minimally different but generally identical for every LED. The maximum duty cycle differs quite much. For red it is 11.2%. For all other colors it is 25.3%. On the right of the table there is the current during the pulse, the corresponding power per color, power per LED per color, and then on the right the total power as supplied by the dimmer board and the total power per LED. The total LED power is 47.9 watts and the total power per LED is 2.66 watts. This is lower than advertised. It is not even 1/4 of 216 watts to be precise. The red LEDs are being overdriven quite a bit with 0.69 watts per LED and my safe measurement saying 0.43 watts. This is probably not going to kill the LEDs immediately, but it is definitely not perfect. Finally, a quick word on the strobe behavior. I'm only testing the strobe with the menu on the PAR itself, not with DMX. There we can set the strobe value between 0 and 99, and according to the number, the pause time between pulses decreases. The light pulse stays at around 50 milliseconds, and you can see the pause times in the table. Of course, the strobe is overlaid with the standard PWM signal. I did not notice any strobe jitter when fading, and just as a fun fact, they advertised strobing between 0 and 10 Hz, and that is not what I measured with the maximum frequency being almost 30 Hz. I did not test the DMX control. However, I have no reason to believe it is not working as advertised, since almost all fixtures up to today behaved the right way when connecting to DMX. The manual from the package provides the DMX description what which channel does. Sound to light. There is a sound to light function. It consists mainly of a dark fixture that gives a flash when the loudness reaches a threshold. You have several modes for that, which only differ in the color of the flash, which can be RGBW or secondary colors. And then there is one mode where it actually cycles through the colors based on the beat. With this low count of sound to light functions and no way of modifying the sound sensitivity with a dial, the sound to light mode is pretty useless. So just don't bother. As a quick fun fact, on the side is a visible mic writing, which would imply a microphone there, but there is no hole for the sound to enter and the mic is on the other side of the PCB anyway. D. Secret menu. Thanks to the person from Reddit who gave me the idea, I tested if this fixture has a secret menu. To my absolute surprise, it does, and it shows much about the inner workings of the fixture. You get there by pressing the menu button for 3 seconds. However, don't just do that. First, hear me out. In the secret menu, you can set the maximum brightness the PAR reaches when setting the DMX value to 255. Effectively, this is an upper limit of sorts. Secret value number of 255 means that a DMX value of 255, the duty cycle of the according color is 100%. When it is not 255, the fixture takes the secret menu number, for sake of argument being a 16, and distributes it over the 255 DMX values you want to give to the PAR via DMX. This would mean that the LEDs are off for the DMX values of 0 to 15, on the lowest duty cycle for 16 to 31, and so on. From the factory, the values for the individual colors are shown on the table on the right here. I marked them with R, G, B, and U, and in the according colors. You first realize that the values are quite small. This has several reasons. First, the power supply has a voltage that is too high for the red LEDs, so these have to be protected from the high voltage by limiting the power. Secondly, the manufacturer limits the power for all LEDs, regardless of the power, relatively harshly to not run into thermal problems. And as you will see in a bit, the power supply overcurrent protection. This hard limiting comes at the cost of resolution, as seen in this blurry video I took. You can clearly see the jumps in brightness every time the Dmax value reaches a threshold. These also correspond to the values I measured earlier in the dimmer board evaluation. This menu gives you the option to do quite interesting things with the LED PAR. It shows many things, the most important being that we now know where the bad dimming curve for the red LEDs come from. But it also means that this is not set in stone. Later, there will be a section about possible modifications and an evaluation based on that. As a small side note, I listed all the values you can change in the secret menu. For a few, it was obvious to figure out the meaning, and maybe you have ideas what the last 7 could mean. I will gladly test your ideas. Power rating and safety features of the power supply. Then let's proceed to the detailed look at the power supply. The inductor of the power supply has a writing on it that would lead me to believe that this unit has 60 watts of power at 24 volts, a fact that is supported by the writing on the right. The unit has a short circuit protection in the sense that it switches off when a short circuit occurs, and it has an overcurrent protection that kicks in at 100 watts. I like the hot and cold side separation by the gap in the PCB. The power supply is actually compatible with 90 to 240 volts AC from my testing with my beefy variable AC transformer. And last but not least, it is not a constant current power supply, but that is not much of a surprise. The input is fused with 2 amps, the idle power of the power supply is 2 watts, and the full-on power drawn from the wall are 58 watts. If you need, I have written the model name on the bottom. All this seems very good for such a cheap power supply, and I have a little bit more trust in this power supply than I have in the Tier 1 power supply. However, we should not forget that the maximum power of the power supply also means that this power supply is obviously not capable of driving the LEDs at max rated power, and has no chance of reaching the advertised power. And again, I am no electrical engineer, and thus I cannot actually evaluate whether or not this is safe. Efficiency. The only real measurement that I can do is an efficiency measurement. I measured the power drawn from the wall at different power levels. Importantly, my mains power meter is not that precise at low power levels, but for example at 70 watts, this is negligible in my opinion. In the end, the efficiency stays rock solid at 71%. This power supply is definitely not total rubbish from my limited knowledge. I like being angry, and this is why I want to direct your attention to the color coding of the LED cables. Blue cables for green, red for white, white for red, green for blue. Like, what? You had the color-coded cables, just use them. Come on. Modification options and repairability. The main problems of the PAR are, in my opinion, threefold. First, the bad casing. Second, the horrible dimmer curve. And third, the loud fan. And one could argue that the maximum power is an additional problem as well. The first is obviously a matter of taste. I don't like the plastic bombers, and thus, as a small project, I transferred the inners into an old halogen PAR 64. The result you can see there. This is obviously not finished. For example, I did not include the DMX cable leads that I would want to use instead of the fixed plugs. And I screwed the backside up, but you can see how this would look like. And I think it looks quite good. The LED board plus lenses fit precisely in the same place as the halogen lamp, which makes all that quite easy. And depending on your supply of PAR 64s, this is pretty cheap. Only problem is that because of the tube, the brightness of the fixture then gets notably lower. So the case can be fixed quite easily. The loud fan is also fixable with a PWM temperature controller, a DC-DC step-down converter, and a new PWM fan. This should reduce the noise significantly. Unfortunately, the bad dimming curve is not easily solvable. We would need a lower voltage power supply or a better driver board that actually would drive the LEDs with constant current. This is theoretically possible to get, but the economics would never be in favor of this. Just look at the price of 18 volts power supplies in comparison to 24 volt ones, and you look at a many dollar difference. Lastly, the maximum power draw can be solved by buying a new 100 watt 4 amp 24 volts power supply board. I have good experience with the WX-DC 2412. This, however, will only enhance the brightness if you can keep everything cool. And additionally, it is a bit of a shame to throw away a good power supply that is included. So I would just use the secret menu to increase the power level a tiny bit to the maximum power of the power supply, which is by default not even fully utilized, and then be happy with it. And with that, we get to the wrap up and the price evaluation. The PAR works, which is always nice. In terms of the product stack, it is definitely a lot brighter than Tier 1 China product, the 7x12 watt RGBW PAR. I cannot see an immediate fire and health hazard. The power supply is solidly built and has a mini advantage that the cables were neatly managed inside of the case. On the flip side, it is really a lot darker than the Tier 3 China product. The noise level is too high. There are no certifications, and it has the worst dimming curve for red ever. The LEDs are most likely not as advertised, and the power is definitely not as advertised, and that by a long shot. Last but not least, it has a shitty case and a rubbish metal bracket. Let's compare this fixture to other options a person might stumble upon when looking for a fixture online. First, I will compare it to the other Chinese product stack and different Chinese options that are not standard in my definition. The DJworld 18x12 watt RGBW PAR fits neatly between the tiers. However, it does not do so as it is being implied. One would think that you get the same power as the big ones, with just a little worse case. But that is not the case. You will only get about half the power of the 18x12 watt RGBW metal PAR with a big case. And you get that while having a bad case. In comparison to the small 7x12 watt PAR, this is a step up in every regard, but I would say it is not really the stellar deal a person looking for the maximum light for the lowest price would hope for. It is exactly the middle between 7x12 and the big 18x12 watt. It has double the power of the former and half of the latter. It has a better case than the former and a worse than the latter. The flat-cased 18x12 watt PAR I unfortunately cannot test since I don't have that model. Another option in the same price range would be the 7x18 watt RGBW Amber UV PAR. This, however, has significantly lower light output with a relatively unusable amber and UV color. But maybe that is what you're looking for. However, the biggest difference is that the 7x18 watt would have a way better case than the 18x12 watt unit we are reviewing today. And now a quick comparison to quality China imports, like my standard comparison unit, the Stairwell 5x8 watt RGBW. In comparison to that, it has definitely a way higher brightness output. But that Stairwell has a great case, and it is more trustworthy than any Chinese light I tested. And it only costs double. For the same power level, I would see the Ignition LED Mini Studio PAR 1 40 degrees or 25 degrees. Those have 70 watts of light output and a great case, but you can buy almost 4 DJworld fixtures for one of these Ignition ones. And for a non-Thomann unit, we can compare with the Eurolight LED SLS 12 QLC floor for 125 euros. This, however, has an imperfect case as well and only 40 watts of power, so I don't really see the value here. Personally, I would not buy this PAR. It is not dangerous, however, there are no certifications and it does not possess enough light output to count as a front light or wash light. And the red dimmer curve is the worst. There are situations where a smaller light might be of interest, for example in the home party room. Then you could go with the 7x18 watt RGB amber UV PAR. Or you are on a real stage and need real output. And then I would rather step up a tier and buy the 18x12 watt PAR with metal cases from China, or the Stairwell CX30 from a reputable source. If I really needed this in between 60 watt power level, I would consider the PAR. But as stated, I really don't like the whole package you get. But I won't dissuade you from buying it. I just don't really see the reason. And obviously, you need to be okay with the bad dimmer curve and the noise. The neat thing is, you don't need to do what I tell you to do. You have all the information on hand and can decide what is best for you. For the moment, the only thing left for me to do is to thank you for your attention. May your path be illuminated by a bright but not burning Chinese LED PAR. Goodbye.